Swayam Prabha. Digital India. Educated India.
Welcome back. In lecture 57, we will cover activity based model. This lecture is divided into two parts. So, both lecture 57 and 58 will cover activity based models. The different concepts that will be covered in this particular lecture is what is activity based model, the background of activity based models, how it evolved from traditional 4-stage model to activity based models. Then we will look into the theoretical framework behind activity based models, the different modeling approaches that have been adopted over time, and then different activity based model systems and activity based model components. We will start with long term and mobility choice models, and in the next lecture we will cover the other parts. So, what is an activity based model? So, in the words of Professor Harry Timmermans, models which predict how households organize their activities and implied travel in time and space subject to a set of constraints, and this kind of models are known as activity based models. So, it means basically models which predict how households organize their activities and implied travel. So, travel is implied, and that means it is a result because of activities, and usually how households organize their activities in both time and space, that is the key. And households cannot just organize, do whatever they want to do. They are limited by a certain set of constraints. So, so we have household level activities. Eventually, individuals do those activities, but it is organized in the household level, and it is organized at a certain time, at a certain space, and subjected to a set of constraints. So, this is what activity based model is all about. So, decisions to participate in activities are modeled in an activity based travel model. So, decision to participate in activities is the starting point. So, we also need to understand whether, when and where to participate in activities and for how long. So, these are the key points that we need to start with. And then duration of activities have a value to its participants and needs to be determined. So, we need to, and how do we do this determination of duration? Obviously, duration means if you can increase the time for the activity, that gives us positive utility, and it is traded against disutility of travel. That means we want to reduce our travel time and increase my activity time. So, when I am scheduling my activities, that means for how long I am trying to do my activity. So, I will try to maximize the time of the activity and reduce the travel time as much as possible. So, this entire schedule has to be designed in such a way so that I gain the maximum utility. So, trips are means of traveling between out of home activity locations, and as you can understand, travel is a derived demand in the true sense. So, in the activity model, travel is a derived demand. So, we are not modeling travel directly. So, travel is automatically generated because we will model activities, and decisions related to mode and departure times are made to accommodate desired activity arrival and departure time. So, that means I want to arrive at an activity. So, accordingly I will choose my mode and my departure time. So, this is the reasoning or the thinking process behind a activity based model. So, the primary thing is what activity a household needs to do, and accordingly organize its schedule, organize the arrangement of the different activities, and then determine locations, time when they want to do those activities, and based on those activities I will decide on when to travel, how to travel, means what mode to use, and so on. So, activity based models consider both households as well as the person individually, And that means also that we need to create, and this is done for all households, all persons in a particular urban area. So we cannot so based on survey data, we need to create a synthetic population using micro simulation methods for an urban area, and then we need to apply this kind of model. So as you can understand, activity based model is very disaggregate. That means we not only look at the zone level disaggregation is very small. We look into very small zones. We look into individual households, individual families, and based on the surveys that we have done, we also predict that okay, this household will most likely perform this activity. So based on the type of household, based on different choices of the household, they will perform a certain kinds of activities, which is determined from the survey that we will conduct initially to develop this kind of models. So that means we need to have a survey, of course, will be more detailed compared to our traditional 4-stage model, and at the same time we need to have very detailed data sets, which eventually we need to create the synthetic populations, as we have discussed earlier when we were discussing micro simulation methods and all. We discussed how to create synthetic population for an urban area, and that method we are also going to use over here as well. So activity schedule also needs to follow several constraints. Like for example, one person cannot be at two places at one point of time. One person needs to do certain kinds of activity in a particular day. Certain activities are fixed, and in certain cases two persons needs to travel together. So there are several constraints that also comes in, which needs to be considered. And some new dimensions also could be considered when we are doing activity based models, such as substitution or trade off with in-home activities. That means activities which are performed in home is also part of our entire modeling process. That means sometimes people don't want to go outside, they want to, if that activity could be done inside their house, what's the point of traveling outside? So that was not possible to be modeled in the 4-stage travel demand models. So this is possible over here. So now we can model telecommuting from activities from home. That means what is the chance that a person will telecommute, and then if he telecommutes, when he telecommutes, and that means work from home. And at home, social and recreational activities, that means sometimes I don't need to go outside. I will, if I have got limited time, within my time I am not able to that is not adequate to reach the destinations that I want to. So I may do that particularly in home as well, that particular activity. And so time at home to take care of children, these are the things that also could be included in the model, and that actually gives us a full activity profile of an individual and an household. And once that activity profile is there, then we can use this profile to model many things, not only travel, we can model other things as well. For example, we can model what kind of pollution or these people are subjected to. So I know both in-home time as well as out-of-home time, and within out-of-home time, how much time was in office or factory, or how much time I was on road traveling. So that gives me exact idea about how much amount of pollution, indoor pollution or outdoor pollution a particular person is exposed to. So that is how this kind of models are providing me a full profile of a person's activities for a full day. So why and how, why activity based modeling, and how do we do that? We want more disaggregation of the travel behavior. We want to model disaggregate behavior so that we can model a person's activities in more detail. And also we need to understand the variety between different individuals. So that is why disaggregation is required. And how we can say that there has been a lot of advances in statistical and econometric estimation methods. There has been quantum leap in computational power, and these are the reasons why we can do activity or this kind of micro simulation and this kind of modeling. And finally, we can also answer a lot of policy questions with complex behavioral implications. So we will discuss some of these examples. So when we make certain changes in policy, it affects a person's activities as well as schedule in a myriad, in a lot of variety, in lot of ways. So that actually could be answered when we have this kind of when we perform this kind of modeling. So let's look at why we have shifted from this 4-stage model to activity-based model. Where were the limitations and what this 4 activity-based models overcome. So the first reason is of course integrity, second interdependencies, third is higher temporal and spatial aggregation, and the fourth is the behavioral basis. So when we talk about integrity, so activity-based models are more consistent. So 4-stage model or the 4-stage travel transportation planning model, these were not that consistent. Why? The travel time for from assignment model was not used in the destination choice model. So that means destination choice first happened, and then we are doing the assignment, and then we are getting the feedback from assignment that this is the travel time in each of those links, and then we can have feedback loops, but at the same time these are not done jointly. So that's that. So there are some inconsistencies in the modeling process. So that is overcome in this particular process. Then reason 2 is interdependencies. So there is very little dependency in the 4-stage models, like between trips belonging to the same trip chain. That means whenever person is making trip from home to office, it is being modeled separately. That means mode choice we can get like transit. Then from office back to home, it is again modeled separately. So we may get mode choice because of our model. It could be predicted like it is a two-wheeler. But actually it is not possible because he has not taken his two-wheeler from his home. So this kind of inconsistencies may arise, or interdependencies are not there. So that means the second trip has to be dependent on the first trip, right? So this kind of dependencies were missing in the 4-stage model. So interdependencies between trips belonging to the same trip chain, or we can call it a tour, between different members of the same household. Like many trips are made by a single person for the entire household. So who will do which trip, that kind of that kind of arrangement within the household, those are not considered. Then between mode choice of members of household, and then trip generation and destination choice and network condition. So these were not consistent. They were not dependent on one another. My destination choice didn't depend on trip generation. Destination, then network conditions and destination choice were not linked together. So all these dependencies were not there, so which is a part of activity-based model. And then comes the main reason, which is higher temporal and spatial aggregation. Instead of peak and off-peak hours, which is the most likely way we split our trips in a 4-stage model, we have in activity-based model we can even go for continuous models, like every minute we are predicting what will happen. That means our mode choices could be done at a minute level as well, or trip choices could be done at a minute level. So time of the day could be any minute of the day. So limited segmentation of households, that was we had only a few categories of household that was possible to be incorporated in a 4-stage model. Then spatial and temporal interrelationship between all trips and activities. These were certain issues. Then activity participation and scheduling, activity linkages and interpersonal constraints. So these are the benefits that the activity-based model gives us. So this kind of activity linkages between activity and dependencies on interpersonal constraint. So this kind of capabilities are given in a present in an activity-based model. Finally, we also look into the behavioral basis, that is in 4-stage models there is misspecification of individual choice sets. That means we are not that aware that what this particular individual is able to get, because we are not considering all sorts of constraints. We may be only looking at that what are the available modes in his particular locality, but because of many other constraints he may not be able to use some of those modes. So this kind of misspecification of individual choice sets or misrepresentation of overall behavior. So this sort of issues were there in the 4-stage model, which could be taken care in the activity-based model. So a quick comparison between 4-stage and activity-based model. We have peak and off-peak in one side, and we could model continuous time periods on the other side. 4-stage models are usually based on TSZs, whereas activity-based model we can even subdivide. we can go to a parcel level or even a plot level, and we can also base it on zip codes. This is for US. We can always make it into pin codes as well, but pin codes is pretty large in the Indian context. So trips, 4-stage model predict trips, whereas activity based model predict activity episodes, which also contains the tour and the trip within each tour. And tour means when a tour starts, the time of a tour, what mode, what destination, all these things are included. And then individuals are considered in a trip based 4-stage model, whereas households are considered in activity based model, but household means the entire household is considered plus all individuals. So 4-stage model, no constraints were considered, but in activity based model we include many constraints which are considered whenever a decision is being taken or a choice is being taken. Those constraints actually decide on what would be the limited alternatives that are available for a person to choose. So that means it gives us a more realistic idea about the alternatives that are available to a particular person. So what are those constraints? There are time constraints, that certain activities beyond a certain time is not possible, or that means a tour is not possible beyond a certain time. So in that sense, we can say that time constraints do play a big role. Then space time constraint, certain activities in certain locations are is not possible and at certain time periods. So those are constraints. Situational constraints, one person cannot be there at two places at the same time. So these are issues. So if you are already somewhere, then in the next decision will happen once that particular activity is over. Then institutional constraint, that means certain capabilities, laws, all these things do play a role in my decision making process. So the image on the right side, you can see over here, we have already discussed this image earlier when we introduced activity based model in one of our earlier lectures. So basically when we look at trip based models, we have individual trips to model, like home to work, work to shopping, shopping to home, then again after coming back from home, home to dining, and dining to home. Whereas when we look into tours, because see, when I go to office, home to work, and then come back from work to home, including a small stopover at a shopping center, that all my decisions are linked. That means when I cannot go to over here to the shopping center unless I leave my work. So this kind of dependencies comes into play, and a tour based model actually connects all the links, all the trips, so that this dependency between trips could be checked. So that's why we have a tour. This is the first tour and this is the second tour. Both are home based tours. That means it starts from home, ends at home. So this is home, dining, home, and the other is home, office, and home. In between there is a stop, which is a shopping center. So but the thing is, when I have got two tours, how do I decide on these two tours? That means if I return from office, then only I can go to the second tour. So that means there are also interdependencies between the tours. So the entire day schedule is actually prepared. We actually fit in multiple tours and then see that, okay, what could be done, and then rearrange our schedule and adjust our total schedule, and then again determine what kind of trips are possible and all. If there are some issues, then we again rearrange our schedule a little bit. So in that way we model our activity. So this is that schedule that we are talking about. This is the schedule for the entire day, and this is actually prepared in an activity based model. And once you prepare the schedule, automatically everything is linked and everything is dependent on one another, and it's a joint decision for the entire day. That means I decide my entire day's schedule and everything else is the outcome of that. That means I first determine what are my major activities for my day. They may have a certain time already, the time constraints are there, so I already fix that. Then I move into the next item, that means what else I can do in that day. So if these are the choices, so again these choices are decided based on my observations from the sample, based on what people do actually. Based on that we take so we determine that, okay, a person can do this, he can do there are 3 things he can do, and for each of this decision he can take another 3 things. So in this way, if I analyze the data that I have got from the sample using maybe decision trees or certain rules, then automatically I can also use the same probabilities at each of these particular junctions, that what I do, these are three options, we can repeat those same probabilities and determine what a person in front of me with this socioeconomic background, this household characteristics, and this kind of choices that he has already got in terms of cars and all, how he arranges his schedule. So that's based on the sample, we will determine that. So there are a lot of, in addition to all this, there are a lot of interactions that exist between households within, like task allocation, car allocation, joint conduct of activities. That means some activities are performed by two individuals of a household together. Sometimes there is only one car in the household, who will use that car. Sometimes a task has to be done, like I need to buy something from the market, who will go to buy something from the market. So this kind of when we were doing tours, trip based models, then we would have directly allocated it to somebody, and it may be right, it may be wrong, but over here it is more consistent. That means we actually check that based on the constraints and based on everybody's schedule, who is able to do that particular activity, or is our activity being conducted together. Means it would be only conducted together if both of them are free at that point of time. Means suppose both of them has completed office, and then there is a free slot for both of them where they can conduct that joint activity. But in a trip based model, these were not there. That means these feasibility checks were not there. That means those were individually modeled for both the persons. So this is a very famous picture. This is from the thesis, PhD thesis by Baumann, and this was cited by Ben Akiva as well. And so in this we actually show the why we require a activity based model, and how this kind of models can help us to choose very complex policies. For example, this is my activity schedule, the one image that you saw just earlier. The same activity schedule, only this we are looking into only one of those tours, work, shop, and then back to home. So this is this great portion is the peak hours. That means I start from home, I travel to work using my own car, and this during peak hour. Then I come back from home, come back from office again during peak hour, and in this process I stop at a shopping center, spend some time there, buy some groceries or something, and then I again travel and then come back to my home. So this is what I can do. Now suddenly what happens? There is a toll introduced. So what I could do? That means when a toll is introduced, like in a particular area, then I can first thing that I can do is I can change my mode. That means over here instead of choosing car, suppose this one is a bus. So I first change my car to a bus. So that means if I go by a bus, I don't have to pay that toll. So this toll is nothing but congestion pricing. Like many cities try to introduce congestion pricing during peak hour to reduce the number of people using cars. So this city has also done that. So I now want to see what kind of effect it may have. So the first effect is a person may choose to use a bus. So he travels during the same time, he uses a bus, he goes to work, again uses a bus to come back, and after he come back, he uses his own car to go to shopping center and then do this tour. So this becomes the first tour, and then this becomes the second tour. So see, one tour becomes two tours, and also this mode has also changed, right? So this is the change that has happened. This is one obvious change that can happen. The other change that can happen is this person is so prone to use his car, he is going to change his travel time earlier. That means he will leave for office before the congestion pricing toll is charged, and so he will start early, reach his office before the peak hour. So his time of the time will change of his trip, and then he will work, and again he will start before, and then he will come back home, spend some time at home, and then go to shopping using his own car. The third is he may decide to work from home, that means telecommute. He will not go to office at all. He will, during the middle of the day, he will choose to go to the shopping center when it is very empty and do his or her shopping and then again come back. So, see, these are three alternatives that can happen when this kind of policies are taken. So, it is not possible to be modeled using a trip generation, 4-stage trip generation model. So, until unless I have an idea about how activities are scheduled for the day, then only I can use this kind of we can actually determine this kind of responses. So, let us look at the theoretical framework, how this activity based modeling came into being. It's all started with Chapin's work, where land use and transportation he said that land use and transportation routes exist for performing some desired activity, and while activities are fundamental to land use planning, this lead to movements which are fundamental to transportation planning, and study of activity patterns which repeats with time and space will improve land use transportation prediction. So, he was the first to suggest that activities are connected with land use, and then activities leads to travel which is connected with transportation planning, and if this activity patterns could be studied in detail because those repeats, then we can also predict better land use and transportation decision, or we can predict future land use and transportation for a particular area. So, this theory was again worked in, similarly Hegerstrand also worked on this. We have discussed Hegerstrand's time geography theory earlier. So, Hegerstrand explained that the need for activity participation using the time geography theory while considering personal and social constraint. So, he introduced this two things. That means he says that, that there is need for activity participation and there is time and space involved, and that means there is a certain time for it, there is a certain location for it, but it takes into account lot of personal and social constraints, and accordingly the schedule or the activity is determined. So, this constraint was actually introduced by, the concept of constraints was introduced by Hegerstrand. So, what are the constraints? There are capability constraints, like activities of an individual are constrained by his physical limits. He cannot do certain things beyond his physical capability, like he need to sleep for a certain amount of time, he need to eat. So, he cannot do continuous work all throughout the day. So, those are the things. Then coupling constraint, like where, when and for how long the individual has to join other individuals and items to perform some activity like produce, consume, transact. So, these are the, that means which are things which are done jointly or together, and where these are done, when these are done, this kind of constraints comes into play. Then there are authority constraints like conditions based on power or legal status, certain rules and all. So, these are the different constraints that were introduced by Hegerstrand, which could be considered while deciding on a person's activity participation. So, this then Cullen and Godsend determined, they were the first to give a framework for individuals' activity time space decision process. So, individuals, they said that individual perform activities with imperfect knowledge in conditions of uncertainty, and that means people do not know all the things and they perform their activities with imperfect knowledge, and the behavior is not consistently rational. People do not do the exact same thing every day, but at the same time activities are found to have a certain structure and pattern. So, even though there is variability, there is uncertainty, there is imperfect knowledge, there are still certain structures and pattern in a way a person does his activities, and that actually could be determined. And this is also limited by certain constraints such as economic constraint, physical constraint, institutional constraint, social constraint and accessibility constraint. And this also vary during different planning horizons. So, this is more or less advancement of Hegerstrand work. So, the constraint remains, and at the same time there is a need to now determine structure and pattern of activities. That was first proposed by Cullen and Godsend. And finally, Jones et al. Combined theories of both Chapin and Hegerstrand, and there he suggested household members perform activities due to physiological, psychological, economic and social needs. So, household becomes the key for activities, and these activities require travel, and households need to schedule these activities on a daily basis subject to set of constraints. So, this was the starting point of activity based modeling. So this theories actually strengthen the way we should model activities as well as resulting travel out of these activities. So now let's look at the modeling approaches. Initially, the models were constraint based models, like you see Hegerstrand's work, and then there were these time space prisms that we have discussed earlier. So these were constraint based models during the 1967s, and then discrete choice and utility maximization models were gradually adopted, and we have seen several models developed in these principles. And as you can understand, these models were based on the utility maximization theory. That means a certain combination when we could also have like single decisions or joint decisions, like all activities are joint decisions of lot of things, right? So both time of the day, location, so all this together makes up a decision on an activity. So these are all joint decisions, so there are dependencies. And we have seen a lot of nested models have been developed in this to solve these joint decisions. And this kind of models came into play during the 1978s. And then came the around 2000 computational choice models started. Why? Because these are very like the more amount of activities we propose, the more segregation we do, the total computing load increases to a huge extent, and it's difficult to solve this using utility maximization models without actually simplifying the model. So we can go for lots of decision hierarchies if we have this some other ways to decide. So that is where computational process model comes in, where it takes in certain aspects of machine learning or learning algorithms, and using decision trees or DR sets, people started developing this kind of models. So this is the computational choice models, and most of the current models both use utility maximization as well as computational process, but the most famous one, Albatross, in this activity based modeling space, is based on computational choice process. Just a quick summary of this different models. Constraint based models, we say that the behavior is primarily influenced by various kinds of constraints, and whether activity agenda is feasible in a specific time and space, that is being checked. And finally, the output is check of feasibility of schedule, social exclusion, and potential action space. So that is the final output. Some of the early models in this regards were Carla, Starchild, and Amos. So Amos, this was by Kitamura, then Starchild was by Reker, and so you can see the timeline were around 83 to 93. This was the time period when this kind of models were developed. So these were used in some areas. Then the discrete choice model, where random utility theory was used. Individuals maximize the utility of the schedule, that we have learned earlier. So here we maximize the utility of the entire day's schedule. So instead of maximizing utility of a mode choice or a destination choice or a location choice, we maximize the utility of a particular schedule. And it is based on a linear function. We know that any logistic regression model is based on that linear function, and the predicted choices for set of travel choices facets. So that is what is outcome. And some of the models which were very important were city ramp, same depth. This is by Pinjari and Bhatt. This one is popularly used, and day sim. And these are the different models in this particular developed using discrete choice. And finally comes the computational choice process. These are based on context dependent choice heuristics. That means based on constraint, certain choices are available and we need to choose out of those choices. And it's the heuristics are being utilized, and the focus is on the scheduling process as opposed to outcomes. So that means we first determine the schedule, and automatically outcome is a result of that. So this was something new in this computational process models. And here we use lot of decision trees, and we arrive at DR sets, decision rule sets, and there are rule based formalism. So we have rules. If this is yes, then do this, or this kind of decision making was there, and the output is simulated individual space-time trajectories. That means we simulate for a synthetic population, we are determining their space-time trajectory all throughout the day. That means where they were in location and at what time at what location, and that is what was determined. So, very famous models, Albatross, Tasha, most of these models are currently also under development, Feathers and Adapts. So, these are the different models, and some of these models are also variants of Albatross. So, these were the different models that has been developed over time for computational choice models. So, overall structure of the activity based models, because activity based models cannot these are not standalone models, this is part of a land use transport interaction system. So, of course, we have a regional economic model which predicts the socio-economic characteristics or the macroeconomics for a particular area. Based on that, we have a demographic model which takes care of the demographic projections and all. We have a land use model, and then we have a population synthesis model. This part is more or less same as what we have discussed earlier. So, we have all this. We can always in the land use model have real estate model, location choice models, all this within the land use model. Demographic model can have a lot of other division of socioeconomic groups. We can do those kind of categorizations, as well as we can, based on that, we can develop a population synthesis model for our entire urban area. So, after that we need to do this activity based model. So, activity based model actually includes long term choice models such as work location, automobile ownership and all, and then based on those long term choices, I would call them lifestyle choices or mobility choices, then the daily activity pattern of given synthetic population is also determined, and which includes his activity purposes, locations, timing and modes of access. So, based on long term choices of an family or an individual, we determine his daily activity profile, and based on certain constraints, certain responsibilities, certain tools, certain kinds of mandatory activities that he needs to do. So, this is developed for each and individual synthetic population in a household, and we determine this the entire gamut of activities, locations where they take place, the time of those activities and what modes are used to access those activities. So, once we know that, we know the destination like location, and we also know the mode use. So, this we input into the network model. That means, this is sort of link assignment or traffic assignment model, where this is the fourth stage of our modeling process in for this 4-stage travel demand model. So, this part remains same, and there are certain other auxiliary models like freight and special purpose travel, like trips to and from airports, travel made by visitors. These are all included in the auxiliary model. So, these also are give their inputs to the network model. So, overall the network loads and all gives a feedback. So, this can give a feedback to the activity models, this can give a feedback to the auxiliary model, and finally, based on this network models, we can also have emission models along outdoor emissions models as well. So, interzonal flows predicted by ABM and auxiliary models are assigned to roadways, transit and other networks to generate estimates of volumes and travel time as per time of the day and mode, and there are feedback loops also to the previous models as well. So, this is the basic activity based model system. So, some of the components of activity based model, I already told you, there is long term choice and then there is daily activity schedule. So, within the long term and mobility choice models, we have already done this kind of models earlier when we have discussed land use transport interaction frameworks. So, it is the exact same thing. These models are actually precondition and puts activity generation and scheduling choices in context. That means, the daily activity schedule is generated based on these preconditions. Precondition means what cars that the household have. That means, what kind of does the household own a transit pass? What is his location, workplace location? What is his school location? Does he work at home? Is it like when he goes to work? What is his schedule for work? What is his usual mode for work? Does he get a pay to park over there? So, this kind of system does he avail? So, this kind of basic decisions, which are long term decisions, which is not influenced by daily activity pattern, or which actually is not related with daily activity pattern, but daily activity pattern depends on this kind of decisions, right. So, if I already have a particular walk time and I have a particular workplace location. So, my daily activity pattern would be based on that. So, that is what is being decided at this level. So, long term choices are first determined, and once that is determined, based on those choices, all lifestyle choices I would rather say, and lifestyle choices and location choices and maybe time of the day choices as well, I decide on my activity schedules for a particular day. So, that is being decided over here in long term and mobility choice models, and this part remains same as what we did earlier. So, just look at an example of workplace location choice. The hierarchical choice of workplace could be something like this, where does this individual, this is those decision rules that I was talking about. So, these are decision rule sets that we need to determine, like does this particular individual participate in a labor force? Yes or no? If it's yes, then which industry is employed? Then there are choices of different industry. And once these are all determined by probabilities of the sampled population. And based on his choices, what is his usual workplace? So, there is it could be either home or it is not home, means it's a factory or it's a office somewhere. And then if it is not home, then his work location is location choice 1, location choice 2, location choice 3. This is based on this particular industry. So, this particular employment industry, where are these industries already there, and this data set has to be present earlier. So, this should be there in my land use data set. So, when I have coded those industrial employment patterns in different zones, we also coded as per that particular industry. That actually gives us an idea where this kind of jobs are located. So, those would become my alternatives for location choice for this particular individual. So, similarly, if my choice is 1, this is fine. If my choice is maybe I, then these are the occasions. So, in this way we will go, this is the hierarchy of the decision making process. So, spatial resolution could be zone, microzone, parcel. Workers could be also matched with the jobs like employment industry. Then destination choice, usual workplace location. This is the mobility model, and day of workplace location, part of daily activity pattern model. So, that means maybe my workplace changes as per the day. So, day of work location could be also important, and work at home, full time work at home, telecommuters, part time work at home, work at usual workplace and work at home in the same day. So, work at usual workplace and work at home in the same day. This could be the 3 options. So, there this is an example where we are showing does he work at home or not home, but we can have work at home or telecommuters or work at usual workplace and also work at home. So, there could be, or just work at workplace. So, there could be several choices. So, as you can understand, this could be solved by multinomial logic or nested logic. So, we have already discussed this kind of choice hierarchies which could be solved using utility maximization. But at the same time, in the computation process model, decision trees are used to determine this kind of decisions. So, in the next lecture after activity based model, we will learn about decision trees, how people take these decisions, how this kind of models are run. But at the same time, this is over here we can either use utility maximization or some machine learning algorithms as well. So, finally, we can also talk about school college location choices, like spatial resolution could be same zone, microzone or parcel. Destination choice is usual school location, which is mobility model, or day of school location based on daily activity pattern. What could be the approaches? It could be a deterministic approach, like children go to the nearest school from their house. That means children are studying in government schools, so they go to the nearest school in that way. But if they are going to a private school which is far away, then that cannot be determined over here. So, for that we may need to have a location choice model. But if I look at students, we can have separate MNL model by students of different grade levels, like primary school, secondary school, high school, college. And student can also be matched with enrollment, like based on each zone how many students are enrolled, that could be matched with the total number of students that wants to go to a particular zone. So, those kind of competition effects also could be considered. So, finally, we can also model the vehicle availability, auto ownership per household. So it could be a multinomial logic structure, like household have got 0 cars, 1 car, 2 car, 3 car, or it could be a nested logic structure with household with no vehicles, household with vehicles, and vehicles again subnest is there, which is 1 car, 2 car, 3 car. So we can use nested logic approaches also to determine this long-term choice, like this is for auto ownership, location choice for school, location choice for employment, and so on. So these are some of the references you can study. So to conclude, activity-based modeling offers an alternative modeling approach to traditional trip or tour-based urban land use transportation modeling process. This also integrates the long and medium-term choices related to destinations and mobility, thus integrated both land use and transportation. And finally, activities are keys to the modeling process, and daily activity pattern of individuals are modeled, unlike trips and tours, thus resulting in more robust and consistent estimates of travel demand for different time periods. Thank you.